I think today's finally the day that we're going to get this heat pump operational. Many thanks to Benoit at ThermAtlantic for talking me through this long process of getting this system installed, especially the control side of things, and also giving me some pointers on getting this heat pump commissioned. So today, overnight, we've had a completely stable, rock solid stable, 175 pounds in the system. So there's definitely no leaks there. And I'm measuring that with the digital transducer on the inside module, the DX2W. So we know it's accurate. So today we're going to start the vacuum process. And so we want to vacuum it down to 500 microns or lower, and then make sure it's stable for a period of time. And then we'll open up the valve to let the refrigerant that's stored in the heat pump into the line set. So from what I've seen, most people are putting the vacuum on the low pressure side. So that's what we're going to do. And initially I've opened up the port for the vacuum service line, just for some place for the argon to go to as I clamp down on this. And it's going. Okay. Oh, of course I have to open the valve. So once that starts getting down to a depressurized state, then we'll add the vacuum onto it. Obviously you don't want this facing me. Argon is quite hazardous to breathe in a confined area or a high concentration. It is an oxygen displacer. As soon as this gets to the point where it's not putting out air or argon to a high pressure, we want to hook it up to our hose so that we're not introducing any moisture into the system. The pump is full. We made sure it's full of oil, and the sight glass is full. We've taken the cap off the exhaust, and we are ready to go. Make sure that's nice and tight. I've just capped off the high pressure line, and the valve is also closed, so we are ready to go. This is now going to go on for a couple of hours. And you can see make sure you can see that. You can see that the exhaust is putting out the argon and gas that is coming off gets heated up a little bit, and I guess there's probably some moisture inside here as well, but that's quite common at the beginning of the process as it starts to suck down. Having a way of shutting off the flow right near the heat pump, eliminating all of the hoses and the gauges is good, so that you have a minimum number of connections that might leak as you're holding the pressure. Something else that I learned on video. So I go to YouTube for a lot of my knowledge in this kind of stuff, but I don't go to other hack homeowners like myself. There's a whole bunch of sites out there that are for basically apprentice technicians. Like HVAC School is one of the YouTube channels, and it's basically pros putting out videos to help people coming into the industry as an apprentice. And you can learn a lot by reviewing those videos if you have the right skill set. And obviously I've been able to muddle through this fairly well, and I think everything's going well. Well, proof is in the pudding when we turn the system on and see how it runs. It was embarrassing yesterday with the regulator and not being able to know that the regulator had a max outflow of 100 psi. Yeah, that wasn't my finest moment. And we went through probably, I'm thinking we went through $350 of gas because we were, when I jury-rigged the regulator to put out more pressure, it was leaking like a sieve, so more was going into the air than down the pipe. But we got it done, and that's the important thing. Benoit has been waiting a long time for me to get this up and going. I actually picked it up from the manufacturer's warehouse. I think it was in June or July of last summer, and it's taken a long time to get to the point where we could start it up. So what we're seeing now is seeing about negative 29, but you want to just keep running it for a couple of hours. You want a really deep vacuum. Make sure you've evacuated all of the moisture, argon, or normally it would be hydrogen, any oxygen molecules. You want to get rid of basically any molecules of anything in the system and just have straight vacuum. That way you're not going to contaminate the refrigerant oil that comes out later on. Something else that I learned from one of these HVAC guys is a good tip is you put your finger on it for about 15 seconds, and then when you release it, you see whether or not any air comes out, whether or not there's any pressurization. And if you do, that means there's still quite a bit of volume of molecules that it's sucking out. And that's not really done anything at all. So we're getting pretty good. Actually, yeah, that's minus 30 now, or minus 29 and a half. I'll go inside and measure it from the pressure transducer off of the indoor unit to make sure, and we'll be monitoring the pressure on that one because it's so much more accurate. Anyway, I think there's no sense you hanging around for 2 hours, so I will bring you back when we're ready to open up the refrigerant. Okay, we've had the vacuum pump running most of the day. Not sure if we got to 500 microns or not, but yeah, we're not sure whether or not the inside sensor doesn't really do negative values that well. But when we had the manifold gauge on, it was pegged at minus 30 psi. So we should be okay. I've also had the vacuum pump off and isolated for the last half hour, and the pressure hasn't decayed. It hasn't gone up at all. So we should be good. And Benoit is indicated to go for it. So we're going to now, I'm going to turn the vacuum pump back on just to make sure that we're not introducing any air into the system as we do all of this, and make sure there's still a negative charge on the hoses here. And then we are going to slowly open up. We're going to create a vacuum, we're going to block it off, and then we're going to slowly open up the liquid line and let the refrigerant out. So let's go ahead and do that. Well, that ain't good. Maybe it needs to start off. Yeah, it doesn't like to start off. It's interesting how it evaporates the, boils off the moisture in the air. Okay, so we're good there. Now we're going to go ahead and start to open this up. And we're just going to let that run for a couple of minutes. In the meantime, I'm going to start loosening the stuff off. Okay, we've had this on a few moments. Now we're going to isolate it and shut it off, and slowly crack open the liquid line on the heat pump, and we'll be able to hear the refrigerant releasing. And it's important to isolate it. You don't want the refrigerant going into the pump. You'll wreck the pump. So I have it. Okay, I can hear it now going through. I'm going to open it really slowly. So Benoit told me to open the liquid line first. Because it's a two-part refrigerant oil, you want it to mix properly. But on the various YouTube channels with the technicians, they sometimes recommend opening the suction line, because if you open the liquid line, apparently you can have it have the oil come out of the compressor. So to counteract that, you just open it really slowly, if you are going to be opening the liquid line for 410A. May as well start taking this one off. Get it ready. The liquid line is a 5mm. The suction line looks like it's going to be much bigger. Maybe a 7. No, bigger than that. So because this is made overseas, it's metric. Yeah, so it's a 8mm. So you won't be able to hear it. It's just a very low sort of hiss that's going into it. And I'll speed this up for you so you don't have to watch the whole thing. That actually didn't take that long. So it's done. Now we'll open that all the way up so it's seated. And that's done. I'll put a little bit more nylon on this, just in case the valve itself leaks. This is going to be a little bit of an extra. Now, if anybody wants to tell me from the HVAC industry, so this is nylon blue. I sent the first one back because I thought it was a bit too glue-like as opposed to oil-like. How sticky is this supposed to be? If somebody can leave a comment in my comment section, that would be much appreciated. Because this is basically almost like a contact cement consistency. Seems to me that might be a bit too viscous. And maybe it's old stock that I'm getting. The system's still turned off. Want to make sure it all equalizes before we turn the heat pump itself on. I've got it isolated at the breaker on the wall, or the switch on the wall. Okay. And I'm just going to go inside and check what the pressure is on the transducer. It's currently showing 133 psi. So it's a lot lower than I was expecting, but I don't know what to expect, I guess. The design pressure on the low side is 240. The design pressure on the high side is 550, but I don't know what the system actually operates at. Remember that this is meant to go with a GREE indoor air handler. And we are mixing it up in a prototype situation with the ThermAtlantic DX2W EX1 indoor expansion exchange module. So it's basically, if I understand it right, it's a spiral heat exchanger. So it has the refrigerant going in one of the pipes and the water going the opposite direction in the other intimate contact pipes to transfer the heat. So I think we are ready to go. I'm gonna slowly open this up. Again, all the way open to the stop. And we're good. A little bit more nylog. Yeah, this stuff is almost like a silicone consistency, which actually it's even stickier than silicone, or more viscous than silicone. But anyway, and of course I should be wearing gloves. I haven't. I did for part of it. But I generally wash my hands 20-30 times a day because I'm allergic to cats, and I have a cat. So now at this point, we're going to loosen off the hose. We want to do it quickly so that as little of the refrigerant escapes as possible. And I'm going to first of all get this out of my way so I can do it better. And I had given it a tiny little tighten with that, so I'm just going to take that off. So there's a depression pin in here that pushes down the Schrader valve that allows gas in and out. And so what you want to do it quickly so you're releasing as much of that as possible, as little of that as possible. So that's that. Now we'll put some nylog on there. And I'm not touching the surface, not that it would matter in this instance. Okay. And that's it. We now have a charged supply line, or line set, and the indoor module will be charged, and we're ready to go. So I'll bring you back when we're ready to start up. Welcome back. Sorry I didn't have you online for the official startup. I had to do some initial tests with Benoit just to ensure that there was nothing going wrong with the heat pump. So we were on a sort of a conference call while we were doing it, and it wasn't a convenient time to tape. And really there wasn't much to it. We turned the power on and the system turned on, and that was about it. So So we've been testing it overnight. It's been running well. The refrigerant charge seems to be fine. We're now trying to, because this is a prototype match between the GREE inverter heat pump and the ThermAtlantic DX2W-EX1 indoor module. He hasn't worked with these before, he being Benoit at ThermAtlantic. So we don't necessarily know the inner workings of the GREE and how it's going to respond to the indoor module. So we're going through a few different tests on flow rates inside on the buffer tank circuit, and now I'm going to be looking at setting the different operating modes. There's a fast response, a normal, and an economy. So I have to figure out what it's on, and then we're going to test the other two as well. And we're just going to see what produces the best overall COP and energy use for the unit. So next, I think what I'll do is I will show you some of the inner workings of Control Core Pro, which is the computer program using MBus to talk with all of these components, and the infinite arrangements that you can make with coding to pretty much code any situation you want to. So that'll be next. Okay, see you soon.